Australia was also they were very, very strict, with their initial lockdowns. They would only let Australian people in, to their country. And so they were really strict, and,
Yeah.
they were able to, same with, Taiwan. Taiwan was really, really strict with their,
Yes.
lockdowns. And so
Yes.
we're seeing like a trend that the countries that, were strict, and I think a lot of that is also cultural. Like, if the people care about public health efforts, and the people respect their government, and, trust their government, at least when it comes to like, public health initiatives.
Mhm.
And two, I think the culture to care about your neighbor, let's
Right.
work on this together, a more teamwork, collaborative effort. I mean, I think there's so many factors that take into place, not just the government,
Mhm.
saying, okay, we're going to lock this down. It has to be the individual, because the government can say what they want to say, but if the individuals don't also care and come together, we're not going to see the outcomes that we want. And so,
For sure.
we definitely have countries that were, a great example, and they're able to, live even without masks now. And the U.S. has been, in this situation. I think we're finally starting to see a little bit of, the light at the end of the tunnel, but
Mhm.
it's too early to really put our guards down, especially when we don't. I would say I would want like 60% of the population of the U.S. to be vaccinated. I don't know if that will, be the percentage that will give us herd immunity, but at least it'll be, over half of the people here that, have been vaccinated. And I think that would just make me feel more safe, that the numbers we're seeing of, the decreasing hospitalization rates and the decreasing COVID rates, that's going to continue on, and it'll just make me feel like, okay, this is more of a permanent trend, and we're going to be good. Like,
Mhm.
let's celebrate,
Right. Now, do you know, just curious, I know, of course, you don't know about every country, but are the other countries following the same trend? It's like being vaccinated and offering vaccinations and things like that as well?
They are. I know France isn't, their vaccination efforts aren't that good.
Okay.
And I know that the US gave vaccinations to Canada and gave vaccinations to Mexico.
Okay.
But it varies a lot on the resources that country has.
Right, of course.
Um, yeah, the US was buying vaccinations before we even knew the data of, of what the
Preparing.
vaccinations would be. We were just like really trying to secure those vaccines.
Yeah.
But every country varies, on how much resources they have to be able to obtain those, vaccines for their people.
Mhm.
And it varies a lot.
Yeah. Yeah. Especially since, we just kind of touched on like how the numbers have been different everywhere. So, that makes sense.
For
All
sure.
right. So we touched on a lot. We're going to, kind of like double back here and just get more into, the vaccination. And I know we went over its components, and, also I know that, I read that they were using, mRNA, and they previously tested that, but it did not pack well, and they decided to put the mRNA in encased lipid nanoparticles, so that it could be more stable than the test before. So, when you talk about, I know you already mentioned the different, components for the different vaccinations, but when we talk about mRNA, could you tell us just a little bit more about that and what that means, being a component for the vaccination?
Yes, so mRNA was being studied in the early 2000s. The problem was that mRNA is it's very fragile. So it's hard to keep the structure stable. so that
Mhm.
it doesn't become, degraded. And that was one of the hard parts. Like, they were studying it, but they didn't know how to get it inside to the cell so that it would so that it would act in the way that we wanted it to.
Mhm.
And so that was a really hard part. And they started studying lipid nanoparticles, and that would be the structure that we would be able to put the mRNA inside and then be able to put it inside of the body. But even that was a really, really hard to develop, because getting it to be the right size, in a maybe small enough so that the body would think it was just like a lipid that your body naturally creates,
Mhm.
and being able to, to get the response that we wanted. In 2018, the FDA approved lipid nanoparticle that we're using now. And so the reason why we decided to use that, so again, the Johnson and Johnson doesn't use
Right.
this technology. And I think that whoever, I don't know the name of the scientist who made the lipid nanoparticle, but they're
Okay.
for sure, if they don't get a Nobel Prize for their work, I mean, I just don't see
Yeah.
how they're not going to, because this is going to revolutionize science forever. This is a great way to make vaccines. And the reason why is because your body already has all the machinery it needs to be able to read this little message. That's what the mRNA is like, a little message that goes inside of your body and tells your body to make this protein. And so your body
Mhm.
has all the machinery. It just needs a message to tell it what to do. Once
Mhm.
once you're able to tell it what to do, it knows exactly what to do, and it's able to make the protein. The protein is then recognized by, your immune system, and then the immune system triggers a response that will ultimately give you the immunity that it needs to protect you in case this virus decides to come into your body again. And so that's how all vaccines work. Not in the mRNA way, but it preps your body so that next time, it knows what to do when the triggering, virus or bacteria come again. And so the reason why we decided to use this is because it's a fast way, like in the lab, to produce the protein itself is hard,
Mhm.
to get it into the right quantities, to put it into, the vaccine, to make sure that you put it into you know the the fluid that the vaccine needs to be in, so that you get the strong immune response. So
Right.
scientists say that actually it's really hard to make the protein in the lab. It takes much more time to get the right amount, takes more time and, more effort, and it's more expensive.
Okay.
And so, other vaccines like, your, um, other vaccines that we use, like the pneumococcal vaccines,
Mhm.
they use more of a protein. And so more of the older vaccinations, would use the proteins that were made in the lab, and then, we would get it into the vaccine and inject that into the body, and then the protein goes inside of people's bodies, and then we're able to, make the immune system respond. These
Mhm.
vaccines, the mRNA one, kind of just skips all of those processes and goes straight into your body and tells it exactly what to do. And so it's really a genius way of skipping all these steps. Like, why do those steps when your body has, was born with all the machinery to be able to make the protein, read the message and then get to work.
Right. Of course. I think it was an interesting design as well. And like you said, it should definitely be recognized for that. So I guess tying all of that in, a lot of people are kind of just sketchy, about the different components and, what are they being injected with, things like that. So I think that definitely clears that up a bit, and I think they are also a little skeptical about why, if it's been said that there is a 99.9% recovery rate for COVID. So if that is the case, some people are thinking and curious, why should I be vaccinated if there's already such a high recovery rate for COVID? I know that we touched on this, plenty of times, but just to reiterate, what would you say to those who are still curious about that?
Do you mind repeating the question?
Oh, sure. Why should people, why should there be a vaccination for an illness that has a 99.9% recovery rate? I know that, the fatality ratio may be high in the U.S. Is
Yeah.
that part of it?
Yeah, so I think with that it varies a lot.
Mhm.
It varies a lot because different countries have, as high as 4% for case fatality ratio.
Okay.
Um, Meaning that, the people that, are infected with it, 4%, have passed away.
Mhm.
Um, and so it varies a lot. And two, in the U.S. on average, you can say that it's close to 2%. That case fatality ratio is close to 2%. But, again, if you have risk factors, like if you affect like a young, healthy, person, you can say that most of the time, that person won't have anything, won't have any severe infection that will land them into the ICU and intubated. We do have
Mhm.
those rare, we do have those cases, those rare cases where, young people with no, no previous past medical history, healthy, athletic, everything, they die of COVID. And so those are the cases that kind of shake us as doctors,
Mhm.
because we, we fear, and everybody in general, we fear that, we may be one of those rare cases. Nobody wants to be that case,
Of
unfortunately.
course. Of course.
But of course, in your patients that are overweight, diabetic, have conditions, I mean, their risk is a lot higher. So
Mhm.
I think in general, we should care because we have family members that are older. We have family members that are, overweight and diabetic and have heart conditions.
Mhm.
Like, we should overall, it's about 2%, but we should really care because we shouldn't live our lives frivolously and however we want when we have loved ones, we have our neighbors, we
I
have,
agree.
people in our church, people around us in the grocery store that we say hi to that are at high risk. So we should say, okay, I only have a 2%, risk of me dying. If that, probably much lower in somebody like me, hopefully, right?
Mhm.
But, in somebody else, it could be much higher. And,
Right.
I don't want to impose that risk on them. So we should care because we should be caring individuals and we should love and care about each other.
Of course. I definitely agree. Now, just curious, what are your thoughts on just, us we have so many different things that have gone on. We have, different forms of, cancer. We have had, like, the fight against HIV and just like all these other different things. And we have spent a lot of money, towards, a type of a cure, just, helping, others with, these different illnesses and things like that. Um, do you kind of think that it was like, I know you mentioned, whoever